All right, today we're going to look at another number system, this time called hexadecimal. And you can see in hexadecimal, we got the hex for 6 and des for 10. So this is going to be a base 16 number system. All right, so we'll look at how to count. So this is just our decimal system. Remember, we just count like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the decimal system, you have 10 symbols for stuff. And so by the time you get to the digit 9, we don't have any more symbols. So in order to make a number larger than 9, the 9 rolls back to 0, and then we add a carry. And we're back here at the end, and amount of digits here, so rolls back to 0 and add a carry, and so on. And eventually, like, we get to 99, right? And we try to roll, we can't increase this, so we roll it back to 0. So 99 would, this 9 goes to a 0, then we try to increase the next one, and it can't increase, so we roll it back to 0, and then add a carry again. Okay, and so on. All right, so that's easy enough. We all know how to do that. So now let's look at hexadecimal. In the hexadecimal number system, we're going to have a different set of digits. So I'm going to say, we're going to start out with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to have a symbol that represents 10 things and a symbol that represents 11 things and so on. And rather than invent something new, right, what we just used the letters A, and that's 10, and then B would be 11, C is 12, D is 13, E would be 14, and F would represent 15 things. So we have digits here that represent, we have symbols that represent 0 through 15 things. And if we wanted to continue counting, well, I get to the F, and this is going to be the last symbol in the place, or in the list. So what I do is I roll it just like in decimal. I roll it back to 0, and I add a carry. And then I got 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. Then I'll have 1A, 1B, 1C, 1D, 1E, and 1F. Okay? And then the F is the last symbol in the list, so we roll it back to 0, and we increase the next bit over to 1, 2, 2, 2, 3, right? And so on. Now, one thing that's important to do here is, so it's hard to, we don't have words that represent these numbers like we do when we talk about the decimal system, but I am not going to look at this 1, 0 and call that a 10, because it's not 10 things. It's actually 1 past F. So this would be what 16 looks like. That would be in decimal 17, 18, 19, 20, and so on. This would be 31. The 20 would be 32. So you got to resist the temptation to just refer to these by the decimal number that they might look like. Now here, obviously, we don't have words to describe those at all. We wouldn't make that mistake, right? So we can continue this pattern. Eventually, we'll get to, right? We'll roll in and we'll get to a, like we're in the nines column, and we'll get to 9, 9, and then there'll be 9A, 9B, 9C, 9D, 9E, and 9F, right? And after 9F, let's see, this rolls back, and after 9F, what's after 9? It's A. So we got A0, A1, A2, and so on. And then, we'll have like a B0 and a B1 and a B2 row, okay? And we'll do this for a while. And eventually we get to the F row, and you get like F9, FA, FB, FC, FD, FE, and FF. And this is the highest 2-digit hexadecimal number you could make. It's actually equivalent to 255. And so what's next? Well, can't increment the f, so we roll it over down to 0. Try to increment the next f, it can't, and we increase this one, and then 101, 102, right? And this is how the pattern works in hexadecimal. So that's actually 255. That's what 256 looks like, 257, 258, and so on. All right, so if you can count in decimal, all we have to do, all we did was add more symbols to the system, and same pattern as counting in we count the exact same way we do in decimal, so really this shouldn't be too hard. All right, that's it.